Whenever you have i's on the denominator of fractions or roots, we don't want i's or roots on the denominator, so that's where we take the denominator and multiply by its conjugate. Now, when you do the conjugate, we're just multiplying by the conjugate of the denominator, not the conjugate of the numerator. So the numerator, I multiply by the exact same thing that I wrote on the denominator, the 1 plus I root 3. And I did see some people making mistakes because they were doing the conjugate of the numerator and the conjugate of the denominator, so they weren't multiplying both the numerator and denominator by the same thing. Okay, so on the denominator, when you do this, since these are conjugates, all you really have to do are multiply the first ones together. So 1 times 1 is 1, and then the last ones together. Negative I root 3 times positive I root 3 would be negative I squared root 3 times 3, which is 9. So I get 1 minus root 9, which is 3. So 3i squared. And then we know I squared becomes the number negative 1. So I have 1 minus 3 times negative 1. So I end up with 1 plus 3. So my denominator is really 4. Okay, now another mistake I saw people do is on the numerator. I have seen several people just multiplying the first ones and the last ones, like you would with the conjugate, but the numerators aren't conjugates. So the numerators, you have to FOIL it out completely, because these aren't conjugates, because even though they have the same stuff, they both have a plus sign. One's not positive and one negative. To be conjugates, one has to be positive and one negative. So I FOIL out my entire numerator. Oops, I left off the... Oh, there is no I on that one, okay. So 1 times 1 is 1. And then here I get a root 3, I root 3, and then another I root, and then this one, root 3 times root 3 is 9, which would simplify to 3i. So pulling it out, it doesn't look like there are any like terms that I can combine together on this one. So I'm just going to pull out the 1 plus root 3, the plus I root 3, plus the 3i. So even though these last two both had an I on it, I can't combine them together because one had a root and the other one didn't. So, and then that's all over my denominator, which was 4. So then this entire thing right here is my answer, which looks like it's corresponding to the P. This one's going to be done the same way as the last one. I don't want any roots on the denominator. Now, if you want to, where I see that's a root negative 3, I could rewrite this as root 2 plus and then take out the negative by making it an I and then put the root 3. So now I'm going to do the conjugate of the new stuff that I wrote in black, which would be root 2 minus I root 3. And whatever you do to the denominator, you also do the exact same thing to the numerator. Okay, so on the numerator, since there's only a single term on the numerator, I don't have to worry about just foiling. I can just distribute. So then I'll get 5 root 2 minus 5i root 3. On the denominator, since those are conjugates, I just need to multiply the first ones together and the last ones together. So root 2 times root 2 is root 4, which is the same as 2. Then I would get negative I squared root 9, and root 9 is just a 3. So 2 minus 3i squared, and then the I squared becomes a negative 1, so I really have 2 plus 3, which gives me 5. So I have all of that over 5, and then I notice 5 divides into both of those. So 5 root 2 divided by 5 is root 2. Negative 5i root 3 divided by 5 is negative I root 3. So that right there would be my answer, which looks like it corresponds to L. Okay, so on this one, again, we're just going to do the conjugate. So that's going to be 1 plus I. And then I do it to the numerator, 1 plus I. So when you look at the numerators are not conjugates because they're both plus signs. So the numerator has to be FOILed out completely. The denominator, I can just multiply the first ones together and the last ones together. So 1 times 1 is 1. Negative I times positive I is negative I squared. And then I saw some people making a mistake in making this just 1 minus 1 and making a 0. But it's 1 minus, and then you replace the I squared with a negative 1. So it really becomes 1 plus 1 for 2 for the denominator. And then on the numerator, I have to FOIL that out. because they are not conjugates. So I do 1 plus I times 1 plus I. So I get 1, and then I, then I squared. So combining like terms, I have 1, and then these two, I plus I is 2I, and then I squared is the same as negative 1, so then I get plus negative 1 or minus 1. So I can see that this positive 1 cancels with the negative 1, so my numerator simplifies to just 2I. So then this ends up equaling 2I divided by my denominator of 2, which is just I, which looks like that corresponds to the answer of O. Okay, so on this one, it's just a FOIL problem, so I'm just going to go and do the area method. So negative 2 minus I, 4 plus I. So 4 times negative 2 is negative 8. 4 times negative I is negative 4I. I times negative 2 is negative 2I. I times negative I is negative I squared. And then I know that I squared becomes negative 1, so this is negative times negative 1. So that's really a positive 1 right there. So then combining like terms, I can do negative 8 plus 1, which gives me negative 7. I can combine these two right here, the negative 4i and the negative 2i. So negative 4i plus negative 2i is negative 6i. So multiplying by the conjugate, I'll have 4 minus 2i. And I have to do the same thing to the numerator, so I multiply it by a 4 minus 2i. So since the denominators are conjugates, I'm just going to multiply the first ones and the last ones. 4 times 4 is 16. 2i times negative 2i is negative 4i squared. Again, I squared becomes the number negative 1, so I have 4 times negative 1. So I have 16 plus 4 for 20 for my denominator. Now, since the numerators aren't conjugates, I have to FOIL those out. So I have 3 minus 5i, 4 minus 2i. So 4 times 3 is 12. 4 times negative 5 is negative 20i. Negative 2i times 3 is negative 6i. Negative 2i times negative 5i is 10i squared. And again, the I squared becomes a negative 1, so that's 10 times negative 1, or negative 10. So then combining the like terms, 12 plus negative 10 is 2. Negative 20i plus negative 6i is negative 26i. And then that's my numerator. I still have to have it over my denominator, which is 20. And then I can recognize both of these numbers go into 20. I can reduce that. So 2 over 20, that reduces to 1/10. 26 over 20, that reduces to negative 13i over 10. And since they both have the denominator 10, I can just write 1 minus 13i all over 10 like that, which corresponds to the letter S. So on this one, I can go ahead and multiply the negative 3 with the 6 and get negative 18. And then I times I is I squared. And then I would distribute the negative 3. So negative 3 times negative 7 is a positive 21. Negative 3 times 6i is a negative 18i. And then over here, I know I squared becomes negative 1, so that's negative 18 times negative 1, which becomes a positive 18. So I have 18 plus 21 minus 18i. So 18 plus 21 gives me 39, so I have 39 minus 18i.